Have you been in the market for display, online or at the store? You'll notice that the technical specifications vary widely between different displays. There are different options, different specifications, and a number of different settings that differentiate one display from another. We also have to consider how this display might be used. Are we going to use it for gaming? Will it be used for watching video presentations? Will this simply be a display that's hanging on the wall in a lobby? Once we know how a display will be used, we can then reference the technical specifications for that display to find exactly the right display for that particular use. One technical specification we may want to pay attention to is the pixel density. This tells us how many pixels are contained within 1 inch of that display area. If you're in a different part of the world, this might be the number of pixels per centimeter. This allows us to put a physical number on the clarity of this particular display. If you have a higher pixel density, the display will look much more crisp and clear than a lower pixel density. You also have to think about how this image will be used. Is this an image that will always be displayed on a screen, or will we need to print this image out onto a printer? If so, we may want to look at the printer specifications and determine if the DPI, or dots per inch, on the printer can properly represent the image that we're seeing on the screen. You can start to see the differences in pixel density when you start comparing how many pixels you can fit into a 1 inch by 1 inch area. If it's 1 pixel per inch, then obviously we have a single pixel in that square inch area. If it's 2 pixels per inch, you can see that it is 2 pixels across and 2 pixels down. 4 pixels per inch are 4 in each direction, and 8 pixels per inch are obviously 8 in each direction. You can start to see how an image on an 8 ppi display would be very different than the image displayed on a 1 pixel per inch display. If you wanted to calculate this, you could take the number of pixels and you could divide that by the number of inches. Obviously, if you were in a different part of the world, then that might not be the same measurements, but for the United States, we will use inches in this particular example. So let's take, for example, a 27-inch 4K display. This means the size of the display is 27 inches if you measure on the diagonal. If we were to measure the width of this 27-inch display, it is approximately 24 inches wide. And since we know this is a 4K display, there's a total of 3,840 pixels on that horizontal display. If we then do the math of dividing 3,840 by 24, we get a total of 160 pixels per inch. Let's take exactly the same resolution of 4K display, and now let's make the total size of the display a 65-inch display. This means that we still have 3,840 horizontal pixels, but the width of this television is much larger at 57 inches. If we then divide 3,840 by 57, we have a total of 67 pixels per inch. So although the image itself may be at exactly the same resolution on a 27-inch and a 65-inch display, you can see that the pixels per inch are very different between those two displays. When we look at a display, we're not looking at a single image. We're looking at a series of images that are constantly being refreshed on our screen every second. And you'll notice that a number of specifications for these displays describe just how many times they can refresh this screen in a 1-second period. This is referred to very generically as the hertz that are supported by this display. Hertz is the generic term for the number of cycles per second. Sometimes you'll hear people refer to this as the number of frames per second, or FPS, and you could have configured the display so that the number of hertz does equal the number of frames per second. But there's some display configurations that may only update a portion of the display on every cycle per second. But let's say for this discussion that we have configured this display for vertical sync, or V-sync, which means the hertz happens to equal the same number of frames per second. Now we have to think about what we will be viewing on this particular display. If this is a display that will be showing movies in the United States, then we expect that to show 24 frames per second. If you're watching a television show or you're looking at a video online, you're probably viewing that at 30 frames per second. And if you're watching something at a very high speed, maybe a sporting event or you're gaming on your system, then you would expect to have something that can support 60 frames per second or even higher. To be able to visually see the difference between a low and high number of frames per second, I've put these circles on the screen, and I've arranged these to drop at exactly the same rates. However, they will only be updated with the number of frames per second shown at the top, so it might be 1 frame per second, 15 frames per second, or even 30 frames per second. Let's start these going to see what the difference might be. And if you're watching this on a display that is able to give you at least 30 frames per second, then you'll see there was an obvious difference between the 1 frame per second and the 30 frames per second. Let's see it again. We'll watch the one which is very choppy, and that's very different than the 30 frames per second that's moving at a very smooth rate all the way down the screen. As we mentioned earlier, if you're working with content that moves very quickly on the screen, this might be video games or sporting events, then we need a refresh rate that's able to keep up with that speed on the screen. Otherwise, the information being displayed on the screen will look like it is stuttering as it's moving across the screen. But the display is only one part of the overall equation. We need to be sure that the video card or video subsystem can support the refresh rates that we need. And we also need to be sure that the connection type that we're using is also able to support those same refresh rates. For example, if you're using HDMI, the 2.1 version of HDMI supports a 4K resolution at a total of 144 Hz maximum. If you're using DisplayPort, DisplayPort 2.1 supports dual 4K displays, and both of them can run at a maximum of 144 Hz. That's why it's important, if you purchase a display that can support 144 Hz, you want to be sure that your adapter card and the type of connection between the two can also support that refresh rate. We talked earlier about a 4K display and the type of resolution that you can expect with that style of display. That resolution number is referring to the number of pixels on the horizontal and vertical of this display. For example, a 4K display is 3,840 pixels wide by 2,160 pixels high. The larger number of pixels will give us a display that looks much sharper. So if you're looking at an image on a 4K screen, that will look much sharper than the image that's on the same sized HD display. And on today's market, there are certainly standards for different resolutions that you will commonly find, but there are some models of displays that deviate from these particular standard resolutions and might have their own set of resolutions. This aspect ratio of 16:9 is very common across these different standards, but of course different monitors and displays provide different aspect ratios, and you need to get the one that's appropriate for your particular use. If you're watching this video on a 4K display, then you'll be able to see the difference here between an HD display and a 4K display. You can see that HD is a width of 1,920 pixels and a height of 1,080 pixels, and 4K is obviously much larger at 3,840 pixels wide by 2,160 pixels high. If we were to look at both of these displays of the same size, you would see that the 4K display does look much sharper than the display you would get on an HD display. Our human eye is able to view a vast range of colors, but the displays we use don't have the same capability. Our human eye can view a much wider range of color than a display can. We refer to this range of available colors that can be seen or can be displayed as a color gamut. This might be a very important consideration when you're trying to decide on what type of display you'd like to use. If you're working a lot with graphics or some type of images, you might want a display that provides the largest and widest color gamut possible. One way that this is measured is using this CIE 1931 color space. This color image that's in the background is the color image that our human eye can view, and on top of that we represent a number of different standards that are also applied to the displays that we use. For example, the sRGB standard, this stands for the standard red, green, blue, is represented on this screen with this blue triangle. A display that says it is sRGB compatible is one that can display this range of colors. We have a similar set of standards we can apply from Adobe with the Adobe RGB, and the International Telecommunications Union, or ITU, also has a number of standards that you can use when trying to compare the capabilities of one display with the capabilities of another. You'll often find this color gamut breakdown in the technical specifications of the monitor, so I went online and found a couple of monitors that were very similar to each other, although a different size, and you'll notice there is a color gamut option within the technical specs. This particular display presents 100% Rec 709, 100% sRGB, and a 98% DCI-P3. You don't have to know the details of those specifications, but you can look at the percentage to see how closely it meets those standards. We can also start comparing those across different displays. For example, the display here on the top can support 100% of the sRGB standard. If we were to purchase the display just underneath, you can see that its color gamut comes close, but it still is only 95% of the sRGB standard. If you were trying to choose between one display and the other, you would need to understand how these displays might be used. If this was a display that's only going to be used for some web surfing and providing emails, you might be able to get away with a 95% sRGB. But if this device is being used for graphics or video editing, you might want to use a display that better fits that particular color gamut standard. Both of these displays are LCD displays that have IPS technology. In fact, the IPS here even uses different forms of IPS to get a much better level of blacks, which is probably why they get a much larger number of the sRGB standard. One way that you could get the best possible color gamut would be to use an OLED display, because they tend to have the best color representation, and you'll often find that an OLED provides a much better compatibility to these standards than any of the traditional liquid crystal displays. Choose wisely.